So recently I dug out my old Sony Alpha 6500 that I got about 9 years ago. Great camera, even to this day. But I noticed that one of my batteries was completely dead. And even when they worked, those batteries had disappointing performance. It's time to do something about it. I got a pile of old 18650 cells laying around from past projects and a 3D printer. So I thought, why not build my own external battery pack? One that will keep the camera rolling for several hours of shooting 4K video. Here's a bad battery already disassembled. This battery has a capacity of 8.9 watt hours and will allow for recording of about 80 minutes, but it always felt shorter than that. The goal is to make a beefy battery pack using recycled 18650s, repurposing the dead battery's case and BMS, and aiming for 6 to 7 hours of 4K recording. The Alpha 6500 burns about 6 to 7 watts while recording 4K, so to get 7-hour battery life, I need a battery of at least 49 watt hours minimum. Watt hours, by the way, are just voltage times capacity. My 18650s are rated at 9 watt hours each. To hit 49 watt hours, I need about 6 of them. I'm going for a 2 series 3 parallel configuration, which gives me 54 watt hours. These cells are old, so they might not hit full capacity, but it should be close enough to get that 7-hour mark. Here's how I'm going to connect the cells to make the battery. My camera needs 7.2 volts, but each of these cells is only 3.6 volts. To get 7.2 volts, I connect 2 cells in series. That means linking the positive end of one cell to the negative end of another. 3.6 plus 3.6 equals 7.2 volts. Now, to boost the battery's capacity, how long it lasts, I use parallel connections. I take the 3 pairs and connect all the positives together and all the negatives together. This combines their capacity. Each cell has a 2.5 capacity, so 2.5 amps times 3 gives me 7.5 amps at 7.2 volts, and when you multiply them, you get 54 watt hours. And that's it. Series connections for voltage and parallel connections for capacity. It's very easy. Here's the design I made for the case. It's very simple. I didn't put too much time into it because I'm not very good at designing nor using Fusion 360. But here's the design for the cells holder. It's cut in half. I'm just going to print 2 of them and put them together. This is the bottom part where everything sits, and the top case with the hole for the cable. Cool, let's get to 3D printing now. I didn't record myself doing the assembly, but here are some shots of the cells already connected and wired up. As I mentioned earlier, I'm reusing the battery case and BMS to act as a dummy battery that connects to the camera. The wiring was a bit tricky because the original cells had an inverted polarity. The outside casing was positive, unlike the standard 18650s. So I had to carefully match the polarity when wiring the new pack to the BMS. One wrong move and I will have a dead camera. Solder everything up, double check with a multimeter, and we're good to go. Now it's time to test this beast. I hooked it up to the camera and started recording in 4K. After 100 minutes, the battery is at 80% capacity. Some quick math tells me that if 100 minutes it's 20% down, that will be 500 minutes total recording time, or about 8.3 hours. That's way better than what I was expecting, so I'm pretty happy with how it turned out. So there you have it, a DIY external battery for the Alpha 6500, built from recycled 18650s, a 3D printed case, and a repurposed BMS. It's a little odd, but it works like a charm. Would I recommend it? Not really. You can find dummy batteries that connect to any battery bank for similar results. But if you enjoy building things, it's a fun and easy project. I still have a lot of 1850s, so I'll probably make some more videos like this. It's fun making products perform way beyond what they're designed to. Okay, that's all. Thank you for watching.